Good day, fellow problem solvers. Welcome back. So yes, mathematics, equations, unknowns. How do we solve them? You've learned about one method through inspection. Today, we're going to take it step by step by step to develop your answer so that you can know where is the X factor in this question. Welcome back, fellow problem solvers. Algebraic expressions, how to use brackets with multiplication and division. So let's first establish a few rules when we talk about multiplication and division. So first of all, whatever multiplies with 1 stays the same. So let's say, for instance, a times 1 is equal to a. That's the very first rule. Okay, so let's look at an example. 27ab squared c to the power of 7 is equal, times 1 is equal to 27a b squared c to the power of 7. So whatever multiplies with 1 stays the same. The second rule, whatever multiplies with a 0 becomes 0. So let's take 27 ab squared c to the power of 7 times 0 is equal to 0. Very important. And then the third rule is whatever is divided by 0 becomes undefined. So it does not have an answer, a real answer. So later on in life I'll explain to you guys what undefined means and what non-real roots and non-real terms means. But for now, all you need to know is that the moment you've got a number or an expression, doesn't matter what, when you divide it by 0, then the answer is undefined. So you literally write down undefined. So these are base rules. Okay, then secondly, I'm going to talk about factorized expressions and expanded expressions. So a factorized expression is when we've grouped like terms together in brackets. Okay, I'll give you an example of that now. Expanded expression is almost like the opposite of this, right? So this will help you to understand that these two work in conjunction with each other. So expanded expression is multiplying out the bracket from the factorized expression. So let's look at an example. So let's say we have something that is 3a plus 7a. I can literally do the following. I can take out an a because it's common to both of those terms, and then I have a 3 plus 7 in the bracket. Okay? So this is the bracket, this one, right here at the bottom. This is a factorized expression, because taking out a common factor from terms is already a step of factorization. Now, expanded terms is if we say, okay, we've got an a, bracket 3 plus 7, and now we multiply this a into the bracket. Because remember, the bracket means multiply. So we multiply it with a 3 plus that a being multiplied with 7. So what we would then have, if we write this down, is we will have, okay, there's a 3a plus 7a. Now I know that we can write down 10a, but the purpose of this explanation is not to solve this, it's just to show you the difference between expanded expression and factorized expression. I'm going to take it one step further and make it a little bit more difficult. And I'm going to say the following. So let's say this is the next example. 3ab plus 7ab squared. I purposefully use the 3a and the 7a again. Now the moment we factorize here, we ask the question, what is common to both of those terms? What's the same? And we can see the numbers, which are coefficients, we can just use as is. And then the a is still the same. So over here, the a is the common factor. So what we write inside the bracket now is this term, 3ab, divided by the a. What is 3ab divided by a? 3b. And then with the next term, we ask the question, what is 7ab squared divided by a? It will be 7b squared. And this is its factorized expression. We can use the same example over here and say, okay, there is an a bracket 3b plus 7b squared. And now we are multiplying into the bracket, just like with this example right above it. We multiply the a with the 3b, and we multiply the a with the 7b squared. So it will become 3ab plus 7ab squared. Remember, you have to write this in alphabetical order, right? ab squared. Okay, then let's do one division or two division examples as well. And this will not now be based on factorized expression or expanded expressions. I just want to do one or two examples regarding division. So let's say you've got 27ab squared c to the power of 7 divided by 9ab c to the power of 5. It's best understood if you write it as a fraction. 27ab squared. Let me take it one step further. A times b times b times c times c times c times c times c times c. We're at 6 c's all the way there. Okay. This is technically what's written at the numerator. If we go to the denominator, it would be 9 times a times b times c times c times c times c times c. Well, that's a mouthful, right? Now remember, you don't have to write it out like this every time you do the expression. I just want to show you the principle. This c is being cancelled by that one. Like c divided by c is 1. Another one, another one, another one, another one. So 1, 2, 3, 4, 5. There we go. So you can see there's c squared is left. One of the b's will be cancelled by the denominator, and then the a's will cancel out. Now let's look at the coefficients. 9 goes into 27 3 times and into itself once. So 27 divided by 9 is equal to 3. So you have 3, and what remains here? Just use my pen. There's a b remaining and c times c. So that means then 3bc squared is remaining. I'm going to do the exact same example by using our exponent rules, because you've been using that previously, and it's a much easier way to work with it. So we've got the 27ab squared c to the power of 7 divided by 9ab c to the power of 5. Then the next step will be 27 divided by 9. We know it's 3. Then you have an a to the power of 1 minus 1, because there is a 1 and there's a 1, times b to the power of 2 minus 1. Remember, when you divide, you subtract the exponent. And then times c to the power of 7 minus 5. So over here, a to the power of 0 is just 1. B to the power of 2 minus 1 is just b to the power of 1. And c to the power of 7 minus 5 is just c to the power of 2. So I hope this helps you to understand how to work with brackets and how to work with division. And yeah, enjoy. Stay tuned for more, and good luck with your preparation.